All right, so we've talked about properties of circles, and now we're going to start delving into some formulas related to circles and do some problem solving with those formulas. So the first thing, you know with any shape that you can measure perimeter and area, and for a circle, you may know that the perimeter is called the circumference, and area is still just called area. That's how that works. Remember, perimeter or circumference is the distance around an object. And then area is going to be this space covered, the two-dimensional space covered on the inside. So we're not going to go through this whole exploration section of where the circumference formula comes from. At some point in your life, you will probably take calculus and you will learn where all that comes from. But it is related to if we inscribe shapes inside of a circle. So remember, inscribed means to put a shape on the inside. And then, as you can see here, the idea is that the greater number of sides, rather, the closer the perimeter of the shape becomes to the perimeter of the circle. So, for instance, in this inscribed pentagon, if we could find the perimeter of the pentagon, we would know that the perimeter of the circle would be just a little bit more than that. And if we do a hexagon, the hexagon is going to be even closer to the perimeter of the circle. And the same with the octagon. So, if I was to create for instance, a circle that had like a 12-sided figure, it would be even closer. So the more sides, the closer and closer we can get to the perimeter of a circle. All right, so with that, I will give you that the perimeter for the circumference of a circle is going to be pi times diameter. Or, remember, the diameter can also be written in terms of the radius. It's twice the radius. So another formula you might see is 2 pi r. It's up to you which one you use, but just know that both of those are going to give us the same thing, which is circumference. All right, so let's look at two quick examples before we move on from circumference. So the first one, question 4, and we're going to go a little bit out of order, is just asking us to find the circumference. Now, this is, really easy. Circumference equals, we said, pi times diameter. Notice if the radius is 3, then you all should know the diameter then is going to be 6. But there's a few different ways we can write our answer. So there is an exact answer, and that's when we don't actually use pi, because any calculation of that is going to be a rounded value. So the exact value is going to be that the circumference equals 6 pi, which means you literally just leave the pi in there. So you would say like 6 pi inches. And then there are going to be 2 approximations, and your book, I think, is going to specify that we use 3.14 for pi. So if we do that, we're going to get an answer. If I've typed that in, 6 times pi, that gives me 18.84. And that's going to be an approximation. So we're going to use this approximation symbol here. So it's not an equal sign. It's like 2 of these little squiggles. I think we've talked about that before. And then there's a better approximation, and that's when you use like your calculator's pi button instead of actually typing in 3.14. So when I do that, it's going to give me 18, and it actually gives me a lot of digits here. 18 point, I've got 84955, so that's going to be 18.85. That's a better approximation. I just wanted to show you that there are 3 options when you're asked to calculate. So question 5 here next says the circumference is 32. What's the diameter? So they're asking me to kind of go backwards. So I know that the circumference, pi times diameter, circumference is 32. They're telling me to use 3.14 for pi and to solve for the diameter. So to do that, we're just going to need to divide 32 by 3.14. And when we do that, we're going to get that the diameter is approximately, and I'm going to say approximate because we're using a rounding for pi, not the actual pi value. So that's going to be 10 let's see, it says round to the nearest tenth, and my calculator says 19. So 10.2 feet is going to be what the diameter would be for that circle. All right, and then our last question, question 3. I am not going to answer that. We'll talk about that in class tomorrow, but I would like for you to maybe pause the video and go ahead and read that and see if you can come up with an answer. So it's going to say, if you double the radius of a circle, how do you think the circumference will be affected? So see if you can answer that question on your own. Okay, so we talked about circumference. The other formula that you need to know for circles is for area. And again, your book is going to go through this big whole long explanation of where the area formula comes from or kind of how to think about it. And really, you all know the area formula. I think you've seen it before. So the area of a circle, area is going to be equal to pi r squared. And just remember that squared is only on the radius. It is not affecting the pi. So it's just pi times the radius squared. All right, so your book actually has some really great problem-solving questions. So this first question says, a rectangular piece of cloth is 3 feet by 6 feet. So remember, we're talking about circles here, so that should be kind of odd that they specify a rectangle to begin with. It's 3 feet by 6 feet. What's the area of the largest circle that can be cut from the cloth? So the largest circle is going to be one that really should be a 3-foot diameter there. It's obviously you're not going to be able to cut one wider than that, or it wouldn't be a circle. So this here is going to end up having a diameter of 3 feet. What's the area of the largest circle we can cut from that? So if we work that out, if the diameter is 3, then that's going to mean that my radius is 1.5. So area equals pi times r squared. And since they don't indicate what to use for pi, I'm going to assume that that means to use the pi button in my calculator, which I've done. So that's going to be that the area is going to be approximately, because I'm not leaving pi in my answer, 7.07. And since we're talking about area, that's going to be feet squared. All right, our second question says, a slice of circular pizza measures 9 inches in length. So we've got a piece of pizza that's going to measure 9 inches on each side. And if you think about that, if we've cut that from a circle, then that is going to be, that 9 is going to be the radius. So if I want to find the area of the entire pizza, that's going to be the area equals pi times radius squared, so that's pi times 9 squared. Now, I'm just giving you another example. If they wanted an exact answer, we would have said the area would equal 81 pi, and you would just leave it like that. Well, here they're telling me to use 3.14 for pi. And when I type that into my calculator, I'm getting that the area is approximately 254.34, and we're talking about area, so that's inches squared. All right, I have one more little question for you to chew on before we move on to the last application problem, and that is, if the radius of a circle is doubled, is the area doubled? So I want you to kind of think about that. Think about what you know, what we've done before with doubling the size of things, and see if you can figure out an explanation for that problem. Okay, so this last application problem for area is talking about finding the area of a sector. And a sector is kind of like a piece of a puzzle, so you can think about it, or like a piece of pizza. The sector would be like this section, this shaded section in this circle over here on the left. So if we're wanting to find the area, it's meaning we're talking about the area of part of a circle. So there's a few different ways that we can do this. Either way, we're going to need to know the area of the whole circle, which is still pi r squared. And so one of the ways to work this out is to think about this like a ratio. So for instance, the entire circle's area is pi times r squared, and the entire circle has 360 degrees. Well, we can compare that to the area of the sector, knowing that the sector has some specified degree measure, so we can call that the central angle, because that's going to tell us how much of the circle we're really talking about. So if we do that and work that out this way, for this example, we're going to do pi times r squared, so that's pi times 15 squared over 360. I don't know the area of the sector, that's what I'm trying to figure out, so I'll call that x. But I do know the central angle, or the angle of this sector that they're asking me to find, is 120 degrees. So we could just solve this out using that ratio. So you can use your calculator and kind of do that ahead of me. And when I work all that out and cross multiply, I'm getting that x, which is the area of that sector, is 235 this is to the nearest tenth, so 0.6 millimeters squared. So that's one of the ways to think about this, is just to set up a proportion. The other way is to use a pre-designed formula, which is really saying the same thing. And all the pre-designed formula does is it goes ahead and cross multiplies and gets sector by itself to begin with. So to me, this is an additional formula you have to remember, but you're welcome to do that. And that is to say that the area of a sector equals the central angle measure, which in your book they call that M over 360 times pi r squared. So it really is the exact same formula. You haven't changed anything. It's just that here you've got to memorize a formula, where in the other method you're just thinking about it as a proportion. So we're going to be doing some additional problem solving with those concepts tomorrow, but that's all that you need to know for today.